In the previous lesson, we're sectioning and digitizing our mineralization zones based on a geological interpretation. Based on these segments, we string all strings, we will create the Ore model. By the way, today's video is very exciting, so make sure to follow along and apply each step carefully. Let us get started. As usual, from the top, Profile, Geology database. Then drag your database. Before dragging it, make a folder here, set as work directory, projects Surpac YouTube. Then drag your database to screen, Moody database. Database Moody for knowledge, connect it. Then drag the Ore.model.str, drag the str file to the screen also. These are our segments. By the way, saving your work is very important. You can click on save icon from here or from here, right click, save. Also can save file from file menu. File from here, file, save from here. Or you can come to search box here and type SF, enter, save file from here also. It is a shortcut of save file, cancel. Okay, this segment or strings is called a wireframe. First thing we are going to do is determine that average grade of a digitized segment. To do that, first display our drill holes from here, display drill holes, or from icon here, or from display drill holes from here. Draw holes table. Okay, go to trace style from here, table assay, field AU, then apply, define query constraint, apply. Okay, zoom to data extent from this icon. Go to sections, define section, define slicing planes width. Okay, section define method graphically, distance forward 5, distance backward 5, section by interval, step distance 10, then apply. Click and drag defines the cutting plane. Okay, start with this segment in the middle. For example, I want to move, okay, just a second, sections, then section mode. Go to sections, zoom to data extent first, sections, define graphically, 5, 5, backward. Step distance here 10. Okay, we will make it here 40. I want to move from one section to another at distance of 40 meters. Then apply. Click and drag to define the cutting planes. For example, I start this segment in the middle from here. We will choose this segment to determine the grade for it. As you see, we click and drag the line along the trace of the digitized segment. Now you have the digitized segment here. So now we want to determine the average grid of this segment. Sections, digitized segment grid. Okay, digitized segment grid from here, grade. Okay, in this window we have a database. The database we want to do the calculation from. And we have the composite method, length weighted or area weighted. Length weighted calculate the mineralization in grade portion from here, just from here. Length weighted calculate the grade just from mineralization portion from here. And area weighted calculate the grade of digitized segment use of the entire length and width of the entire length and width. This is the difference between length weighted and area weighted. Also we have minimum percent of sample to be included. Here 75%. Okay, if you are sure about your sampling procedure and the drilling activity, then you can enter any percent of samples that you would want to use in your calculation. For example, if we write 75% here, the percentage here accounts for the possibility of errors during the drilling process, such as part of the sample falling into the ground or a part of the sample remaining inside the drilling pipe. Therefore, we don't count the entire interval. For example, if the sample interval is 1.5 meters, if we obtaining the full 1.5 meters after drilling would mean we have 100% recovery. However, in most drilling operations, errors occur, which is a part of the process. Fourth, we need to account for an error percentage. If we set it at 75%, this means we are not going to include all the samples gathered within the 1.5 meter interval. We are saying we want to use 75%, which we will use 3/4 of the 1.5 meter interval. In this case, if you want to calculate 75% of the 1.5 meter interval, okay, let us using our calculator from here. %75 means 0.75 multiply 1.5 equal 1.125. This amount will be used in the calculation of the digitizer segment grid, meaning 1.5 minus 1 0.125 equal 0.037, 0.075 meters, accounting for the sampling error. Okay, we have table assay from here. Table choose assay. This is the grade calculation we use. Assay. In the grade calculation we will use assay result. Fields, choose AU, assay result. Dilute, mark dilute. Is the waste material inside the mineralization or zone, waste material. We have B field here, is a description field that where we want to save our results. Okay, for example, choose D1, then apply. Select the segment of interest. So we click anywhere in the segment as you see, for example here. As you see, my results display in the message window string number. You see string number 1, segment number 1, segment area 2.141, 0.547, AU assay equal 1.348 part per million. Okay, this means average grade 2.3. Press escape. Back to digitize segment grid. From here sections, digitize segment grid. This time choose area weighted with keep other parameter constant. Area weighted and keep other parameter as it is. Apply. Then you notice the difference between area and length weighted, that the area weighted is less than length weighted. You see area weighted 1.9 and length weighted 2.3. Because the area weighted calculate the average of grade from all segments, but length weighted calculate the grade just from the mineralization zone as we mentioned above. Length weighted just calculate from mineralization zone, and area weighted from whole segment and width of the segment. Now clear window. From here right click, clear window. Also for view the results of the description D1 from the same functions, digitize segment grid. Choose from here, escape, sections, digitize segment grid, database, composite method, choose length weighted, then apply. Choose for example D1, apply. Select the segment of interest. Okay. Now if I want to see the result in the description field, I can go to icon above, Inquire here, point properties, then select the point of interest, for example this point, and you will show the grade and point of coordinates. You see the layer all outlined with str string 1, segment 1, this segment number 1, point number 10 here, y and x. These our coordinates. Description equal 2.374764. Okay, now press escape. Geological modeling requires that the string or the segments that will be used in the modeling be clockwise, as we mentioned in the previous video, because to avoid the validation problem, and it helps to create a very simple and well-formed three-dimensional models. To check if a segment clockwise or anti-clockwise, you can go to Inquire, first hide drill holes, you can make it one by one or hide all drill holes at once. From here, hide all drill holes. Then go to Inquire and select segment properties. Then select the point of interest. For example, choose this point again, or any point. Okay, you see. Layer or outline dot string segment description, layer outline segments. You see here status of our segment, status clockwise. Okay, then skip, zoom to data extent, sections, and section mode. We want to see the other segment. For example, sections, define, graphically, 5, 40, apply, choose this one. Okay, hide all drill hole, go to Inquire, segment properties, choose this point. Okay, you see this segment to status anti-clockwise. If you doubt that your segment is anti-clockwise or one of them is anti-clockwise, so you can change the entire direction of the string to be on clockwise by going to File Tools, first here, zoom to the extent, sections, in section mode. Okay, hide all drill holes. Go to File Tools, change string direction. Change string directions here. Changing the direction of strings. Location. We are going to choose our Ore.model.str, open. ID range, str range. If we have another string want to change direction, just add it. For example, 1, 2, 3, and so on. And select make string clockwise. Select the direction, make string anti-clockwise, make string clockwise, reverse existing direction. We will choose this, make string clockwise, then apply. An effect will saved in our work directory file. Then exit graphic from here, from that bottom, reset graphic, and drag Ore.model.str. Okay, drag it and check from Inquire, from here, Inquire segment properties, select any point. For example, this segment clockwise, this segment clockwise, third one status clockwise, and Anti-Clockwise. Now we will make sure all our segment status in a clockwise direction. Okay, now press escape. You must use your geological sense and draw an extension of your Ore model beyond the last segment. So we want to extend or to go beyond these segment or drill holes. So must be created additional segment. So let us begin to do this. First, display your drill holes. Display drill holes. Say, for example, no constraint. Apply. Then go to, we can also display drill holes, geology button, geology, lithology, hole ID. For example, we can show also max depth, then apply. Okay, to make additional segments here and here, go to solid, triangulate, extrude and triangulate a segment. Select the segment to be extruded and triangulated. For example, choose this segment, first one. Extrude and triangulate segment object ID 1. This refers to color. One brown color, for example, we use 8. We want, I want to use red color. Direction to copy segment, forward, and backward. For example, forward. Okay. Copy segments by, we will choose perpendicular to segment plane. Distance, segment copy parameters, distance, for example, 70 meters. From new segment to the original one, make it 70 meters. Slope angle 90 degrees. Apply. Select the segment to be extruded and triangulated. Okay. Very good. To edit or to undo, just press here, undo or redo, undo. For example, undo. You see, redo. Okay. Now bring back our fractions from right click, recent commands, extrude and triangulate segment. Select the segment to be extruded, then select the last one from here. For example, I choose this segment. Okay, now we'll forward and backward. Object ID 8, okay, perpendicular 70, 90. Apply. You will see forward and backward. Okay. Then we need just the segment. We need just this segment and this segment. So go to solid, edit, Trisolation, delete, choose your target because only needs additional segment. We need this and this segment. Okay, escape, and then we want to delete this one we don't need it. Go to edit, segment, delete. We are delete the Trisolation from solids, and we delete segment from edit here. Okay, escape. Okay, very good. Now we have an additional segment to extrude, to extend our ore mineralization. We want to see the number of segments that we have on this graphics. Go to display. Okay, display. Strings with string numbers. You see drawing, layer name. Here choose position of text. We went on the center, centroid. Description field D1. Okay, apply. Okay, this string, we have 4 string. In the origin 3 string, but with additional 2, so we have 5 segments. Now type save in the search window, SF, enter, save file, file name or outline. You notice in the layer window the name or outline change from, after saving will change from red here, or outline red. After saving will change from red to blank. Okay, apply. Verify creation of file. You are about to overwrite the file or outline-str. Okay, yes. Now it's changed to black color. Okay, very good. The next thing is to clean our strings and segments from the results of digitizing and other factor to be ready for modeling. Okay, then go to edit, string, clean, choose clean string, function, crossover, duplicate segment, minimum area, minimum point, spikes. We will start by crossover, action, okay, mark color, red, target, string, okay, crossover, type, all, okay, then apply. Select the string to clean. For example, we select this first one. Okay, you see all this crossover. You see crossover test completed. Attention, all this red triangle is crossover, so you must clean it. Okay, from here right click, toolbar, application, free. You see from this icon, hide temporary markers. Okay, now go to next function, edit, string, clean string, choose duplicate points, mark, target, string here, choose 3D space, action remove 3D string, then apply. Select the string to clean. Okay, 100% complete. 1 point deleted. Very good. Go to the next function. We want to clean our ore from, okay, edit, string, clean. This time choose spikes, action remove also, 3D space, remove with all constant parameters, apply. Choose, for example, okay, finish spike test, warning 0 spikes removed. Very good. That means they have no spikes on our work. Okay, after finish spike test, now after this cleanup, we can be confident that the segment is ready to receive the triangulation and create our model. Save my file from here, or outline, right click, or here, press SF, enter. Or outline, okay. Or we can make it or model. Apply. Okay, very good. Now exit graphic. From here, reset graphic. Drag the file to display window. Okay, very good. Now we are going to model our ore. We are focusing the solid menu this time. Go to solid, triangulate. This time choose triangulate between segments. What is this function? Triangulate between segments mean we want to Surpac to join one segment to another segment by triangulate. Okay. Okay. Define the Trisolation to be created. Object that refers to color. We choose 8, so we want to use red color on our modeling. We want our Trisolation to be red color. If we choose 1, we make it brown color. Object, Trisolation. Okay. Trisolation 1, we can make one object with several trisolation. Okay, we can make one object with several trisolation here. We can make it 1. Okay, define Trisolation to be created, then apply. Select a point on the first segment to be triangulated. Okay, you will choose, for example, this point and this point. Very good. And from this point to this point, and from this point to this segment point, and from this point to this segment. Very good. If you want to rotate your model, press Escape. Okay, then right click, recent comments, and bring back your function. Okay, if we make it undo, we can hear. Okay, from here, recent comments, between segments, apply. After bring back your function, with the same method we are going to join every segment with another one as we did. Okay, from here, this segment, last one, escape. Okay, very good. We want to close the edge. Go to Solid again, Triangulate. This time choose Triangulate inside segment. Object 8, Trisolation 1, apply. And choose this side, then escape. Okay, very good. Now display our drill holes. Let's say AU style, for example, hole ID, add. Then apply. Then click on the toolbar, choose scale and transparency. From here, transparent. Okay, excellent. Finally, we want to be sure everything in our solid model is okay and zero error. So go to solid, choose validation, validate object, Trisolation, layer name Ore.model.str. Okay, very good. Color for highlight invalid triangles. The table showing problem on highlights. Color, holes, green, intersection, cyan, invalid edge, open edge, reverse, triangles, red. Report file, for example, we will name it model report. Apply. Validating Trisolations. Okay, model report, solid validation report. 20 July 2024, layer model.str objects, 8 Trisolation, 1 solid validation reports. Very good. Now save our work. Save function, enter, save file, apply, verification file. You are about to override the file or model.str. Yes. Saved Ore model. Okay, reset our graphic. Ore.model.dtm, drag our file. Okay, very good. Okay, see you in another tutorial. Bye.